Imagine a universe with no stars. A dark, endless night. This is not some sci-fi nightmare. This is our future.
There will definitely be a point in the future when you look up, you will no longer be able to see stars.
Things really will get darker and darker until there will be almost no memory of light left.
For billions of years, stars brought life to the universe.
The fact that you exist at all is because of stars.
Now, they're dying out in a star apocalypse.
The effect could be tremendous. It can permeate throughout the universe.
What's causing the die-off? And what happens to life when the lights go out?
Eventually, the whole entire universe starts to get a little bit weird.
For over 4.5 billion years, the sun has bathed our home planet with light. Its bright, stable glow helps life flourish. But hidden in the night sky, other planetary systems haven't been so lucky.
Hanging right above your head every night, we see up there these dead corpses of stars.
400 light years from Earth lies the SDSS J1228 system. A disk of debris orbits the faintly glowing leftovers of a dead star.
J1228 is a dead star. It is the core of a star that had aged, blown off its outer layers, revealed the core, which is about the size of the Earth, but has about half the mass of the star in it. And we call these white dwarfs.
May 2018. Astronomers investigated J1228 using the world's largest optical telescope, the Gran Telescopio Canarias. They discovered what appears to be a ball of iron orbiting the white dwarf. The lump of metal, less than 400 miles across, could be the exposed core of a destroyed planet. It's a clue to this system's past.
It's always a little poignant when you see evidence of a planet around a dead star. You know, you think back when that star was shining, and could there have been life in that solar system?
The J1228 system is a cosmic graveyard. It might look different to our own solar system, but this is our future.
This discovery of a dead planet orbiting a dead star is like looking into a crystal ball. And is it the future of our own solar system? Yep.
For a glimpse into your future, you know, all you need to do is look up.
Just like J1228, our sun will die, killing off Earth in the process. This terrifying fate will play out across the galaxy in a star apocalypse.
Our sun is a fairly common type of star in the Milky Way, and so other stars in the Milky Way will undergo the same sort of fate as the sun and will end up as white dwarfs. And so any other planets out there orbiting sun-like stars will undergo a similar fate.
Once the stars like our sun have died out, what's going to happen? Could life still survive around white dwarfs?
July 2018. Heliophysicists tried something a little different. They didn't look at a star. They listened.
In a sense, stars are noisy. There is gas moving around inside of them. There's turbulence. There are huge parcels of gas moving up and down. It's not really an orchestra playing coherently this beautiful music. It's more of a cacophony. It's more like just a bunch of people shouting for attention. But all of this comes together to make the surface vibrate, and this is telling us what's going on deep, deep inside the star, which we cannot see directly otherwise.
Just as the seismic waves from earthquakes tell us about our planet's interior, This cosmic performance grants us special access into our sun.
It provides a window into the physics of the interior of stars. What are they doing inside?
To understand the fate of sun-like stars, we must look inside them. Buried within are clues to how they live and why they die.
The core, the very center, that's where the action is. That's where the star is fusing light elements into heavier elements. And that works like a hydrogen bomb. That's the same thing. If you compress hydrogen enough, it gets very hot, and the pressure gets very high, and it fuses into helium and generates energy, heat. And that's what's happening in the core of every star.
Because of their enormous mass, stars have huge amounts of gravity. This gravity pushes inwards, trying to collapse the star. But fusion energy from the core stops that happening.
It's really this sort of very balanced dance between gravity pushing in, fusion energy pushing out.
You can think of a star as losing energy continuously to the outside world, and gravity is saying, yes, I'm going to take over. But no, the nuclear reactions inside a star replenish the energy that's lost and keep the star hot and pressurized inside so that the pressure-gravity balance can be maintained.
This balance keeps sun-like stars alive for up to 10 billion years, until the star's gas tank runs dry.
It's going to run out of fuel, and when that happens, it's going to die. But what is that going to look like? How is this going to happen?
100 million years ago, things in the J1228 system started to get ugly. First, the star grew large, really large.
Once the center starts fusing heavier elements, the outside will swell into what will eventually be a red giant star.
J1228 transformed into a red giant. Its outer layers blew off, extending out over 40 million miles.
When stars like our sun die, it's not a quiet affair. It's very violent and ugly and messy. They turn into red giants, and they turn themselves inside out and vomit all over the solar system.
When J1228 swelled into a red giant, nearby planets were stuck in a kill zone. The dying star engulfed them or fried them with temperatures of over 1,200 degrees Fahrenheit. Atmospheres disappeared. Oceans boiled away. But one planet survived J1228's death throes.
Here's a case where a planet survived, in some sense, the death of its own star, and is still hanging around, still hanging on, hoping for something new.
The red giant's expanding outer layers separated from the star's core. With no active fusion, the core collapsed into a white dwarf. The white dwarf's dense gravity then went to work on the one surviving planet.
A planet that might have been orbiting the normal star can gradually spiral in toward the white dwarf, and then eventually the gravity of the white dwarf pulls on the near side of the planet more than on the far side, and that tears it apart.
What we're seeing here is a dead star dining on its own solar system. That's what is in the future for the sun.
J1228 feasted on the remains of its rocky worlds, leaving behind a disk of debris and the planetary core. It's a glimpse of Earth's future.
What happened here around this white dwarf is going to happen to Earth. It's going to be stripped of its atmosphere, its crust, and its mantle, and the only thing that will remain will be the core.
Fried and ripped apart by a dying star is not a good way to go. Fortunately for life on Earth, our own sun isn't dying just yet.
The sun is middle-aged. It's 4.5 billion years old, and it's going to go on for another 5 or 6 billion years.
We've got a little bit of time before our sun pukes all over the solar system.
Our home planet may be safe for now, but systems like J1228 show us that sun-like stars are destined to die, killing off any life orbiting them. Sun-like stars aren't the only stars dying across the cosmos. There are others out there, and they are all doomed.
There's a wonderful rainbow of stars out there of all different shapes, all different sizes, and all different colors.
We're talking down to, fractions of the mass of the sun, up to hundreds of times the mass of the sun.
When it comes to the star apocalypse, size matters. The bigger and brighter the star, the faster it dies. Our universe is a vast expanse of death and destruction. All the stars are destined to die, but not all at once.
There's not going to be one particular point where all the lights turn off at the same time. It's more like a power outage where different grids go off at different times until there's the one last light bulb that'll just go off.
This is because stars come in different sizes.
The way a star dies has everything to do with the amount of mass it started life with. It carries that all the way through its lifetime.
The sun is a medium-sized star, living a stable existence for billions of years. Giant stars are different. They live fast and die young.
A star like the sun, which is a medium-sized star, it lives about 10 billion years. The really massive stars, they live maybe 10 million years.
Weird thing is, we don't even know why the universe makes massive stars.
Every single type of star forms when a cloud collapses under the force of gravity. For some reason, some clouds decide to make very massive stars. Some make tiny little stars. The difference is still a mystery. We don't really know why a cloud decides to make one certain type of star as opposed to another.
Searching for answers, the ALMA Observatory probed infrared dark clouds 10,000 light-years away. These cloud cores are so large and so dense that they should have collapsed to form stars. The scientists didn't spot any stars. Instead, they detected something surprising: deuterium.
Deuterium is kind of special because it's very easily destroyed when it goes into a star and nuclear burning starts. It'll use up the deuterium very quickly and get rid of it. So if you see a cloud that has deuterium, it tells you that it's pristine in a sense, that it hasn't been processed through generations of stars.
The clouds are teeming with star-building material. But the deuterium shows that stars aren't forming. Something must be preventing them.
If you have a very quiet cloud of gas where the particles aren't moving around very much and gravity can just pull them inward, that would be a cloud that collapses relatively easily. But suppose you have all kinds of turbulent motions within that cloud.
Turbulence could stir the gas, creating an outward pressure that counteracts gravity, disrupting the cloud collapse that triggers star birth.
Those are extra motions against which gravity would have to pull, and it would be harder for gravity to overcome those motions and lead to collapse.
Scientists believe this could help delay cloud collapse in the star-forming regions of the cosmos. Once gravity overpowers the turbulence, the dense clouds of gas and dust can build massive stars. Massive stars can be tens or even hundreds of times more massive than the sun. When it comes to lifespan, that's a problem.
A massive star has more fuel to burn in a nuclear sense, so you might naively think that it lasts longer, but it's the exact opposite.
Massive stars can only access hydrogen fuel in their core. The rest is trapped in the outer layers and can't be used as fuel.
If there's hydrogen in the core, you're good. If there's hydrogen outside of the core, it can't be used. If it's not in your fuel tank, it's not doing you any good.
Massive stars also have more gravity than smaller stars, so they have to burn their hydrogen fuel faster to prevent the star collapsing.
They burn their candle on both ends. Because of their incredible mass, their fusion reactions in the core happen at an incredible rate.
Giant stars are kind of fast and furious. They are bright, they live their life, and they die very quickly.
When a giant star's fuel runs out, the core collapses catastrophically under the overwhelming force of gravity.
And then, boom, supernova.
The death of a giant star triggers one of the biggest bangs in the universe. The blast would instantly vaporize nearby planets. But these star deaths are also critical for life.
When massive stars die, they release heavy elements they've been making through the course of their lives, and sometimes they even make new ones. And it's these heavier elements that are essential for life. We owe our existence to stars that formed billions of years ago.
In May 2018, we spotted evidence of ancient stars creating the stuff of life. We picked up an infrared light signal from a distant galaxy named MACS 1149-JD1. The signal was ionized oxygen. It's been traveling for 13.3 billion years, so the oxygen formed when the universe was very young. Just 500 million years after the Big Bang, this oxygen formed in the hearts of massive stars.
The presence of oxygen tells us that there needed to be massive stars in the early universe in order to synthesize hydrogen and helium into heavier elements like oxygen, and then explode to eject that oxygen back into the interstellar and intergalactic medium.
Extreme pressure in the cores of the stars produces oxygen and other elements like carbon and nitrogen. Supernova blasts spread these elements across the universe, helping to create new generations of stars. And most importantly, us.
If there is one single fact that you should care about in all of science, and this is my favorite fact, is that you and I are a consequence of star death.
Before you can have life, you need to have the kind of elements out of which life forms. You need carbon, you need nitrogen, you need oxygen. You need the elements that are the backbone to the biology that makes us possible. Where did those elements come from? Well, they came from stars. They came from stars that formed in the early universe before even the sun existed.
The huge size of massive stars quickly signs their death warrants. Their explosive ends helps create new stars and even life.
The fact that you exist at all is because of stars.
But probing galaxies across the universe, we've discovered something else. The star apocalypse isn't just killing stars, it's stopping them from ever being born.
Star formation is dying, and in fact, it's dying rather quickly. The universe right before our eyes is becoming a darker place.
It's running out of fuel, and eventually no more stars will be made at all.
Life on Earth follows a series of regular patterns. Day after day, the sun rises and sets, and stars light up the darkness of the night sky.
The reason I got into astronomy to begin with was because I grew up in a rural part of the country and the sky was beautiful and dark. You go outside at night and you look up and you can see thousands of stars. But it won't be that way forever.
2016, a network of telescopes across the world measured the energy output of over 200,000 galaxies. They discovered that in the last 2 billion years, the universe has lost half its brightness. The night sky is getting darker as stars flicker out of existence.
About 10 billion years ago, the universe kind of hit its peak, and lots of stars were shining. It was an incredibly bright place. But in the last couple billion years, it's really overall become a less bright place.
The darkening universe isn't just a sign that stars are dying. It seems there's a problem with star birth as well.
When we look into the universe's past, what we find is that long ago, stars were forming at a much higher rate. Right now, what we see is that really stars are dying off faster than they're being born.
A Milky Way type galaxy today produces about 7 stars per year. However, 11 billion years ago, a galaxy like our own would have produced 10 times more stars.
In the early universe, old stars died and new ones formed in their place from the material left over. It was a cycle that kept the cosmos bright. Not anymore.
It kind of sucks for us. We like a bright universe. We like all this energy and life that's vibrating through the universe, but that's just not always going to be the case. The universe is already winding down.
One of the biggest mysteries in galaxy evolution is figuring out how galaxies stop forming their stars. But we really don't know the answer yet, and it's really important for us to figure out why. Because in the end, stars really equal life.
To find out what is shutting off the stars, we study galaxy clusters. These giant regions of space contain hundreds of galaxies bound together by gravity. Slowly, the clusters pull new galaxies into them, causing something strange to happen.
What we see happening when a galaxy falls into a cluster is that its star formation is quenched, it's shut off.
The cause of this quenching effect has baffled scientists for decades. Then, in October 2018, an international team of astronomers investigated this long-standing mystery. They tracked variations in quenching across 14 galaxy clusters and found a possible explanation.
The ability a galaxy has to make new stars is related to the larger environment it finds itself in. In clusters of galaxies where many galaxies are orbiting around each other, we see interactions that strip gas and dust away from galaxies, the stuff that makes up stars, literally just thrown off into space.
Stars form from dense parcels of cold gas, something galaxies are filled with. But when a galaxy is dragged into a cluster, everything changes.
Clusters of galaxies contain a lot of hot gas, whereas you need cold gas inside of a galaxy in order to form stars. And when a galaxy is moving through this hot gas, then the cold gas inside is stripped away.
If this new study is right, and galaxy clusters are stripping away star-forming gas, new starlight will become rare.
Looking over the history of the universe and how much gas was out there and how much is still left, I think it's fair to say that most of the stars that will ever be made already have been made. They've already been born.
Thanks to the shortage of star-forming gas, stars won't just be dying in the universe, they'll go extinct. And the first to go will be the largest.
As the universe runs out of gas and fewer of these stars are being made, eventually, sometime in the future, all the high mass and even medium mass stars like the sun, they'll be gone. What does that mean for life?
Some of the brightest stars will disappear forever. Can life survive the monsters that dead stars leave behind?
The long-term fate of the universe is not a pretty sight. Some very interesting creatures can start to appear.
In the star apocalypse, the first stars to fade away will be the brightest, the giant stars, followed by the mid-sized suns. The universe will become unrecognizable.
The far future will be a very dim universe, especially for creatures like us. If there's no more gas, no more new stars, it gets dark.
Scared of the dark? You will be. Because 100 billion years from now, in the shadows of this new universe, monsters will come out to play.
Now we find ourselves in the era of stars and starlight. What comes after you could think of as the era of the dead corpses of old stars.
We already see the corpses of dead stars scattered throughout the cosmos. Black holes, pulsars, white dwarfs. What happens when more stars die out and the dead take over? Can life survive?
It's actually possible that life in the universe will survive. But we're going to have to get more creative.
January 2019. The Gaia satellite studied 15,000 white dwarfs within 300 light years of Earth. These are the corpses of sun-like stars.
White dwarfs are the remnants, the cores of stars like the sun after they die. There's no more fusion going on inside of a white dwarf, so it's just kind of sitting there cooling off. But it turns out there's a slight reprieve.
White dwarf corpses usually cool off and dim over tens of billions of years. Gaia's data showed something different, something we've never seen before. Some of the older dead stars aren't dimming at all.
We used to think that white dwarfs could really only dim over time. After all, there's no source of fusion, no source of energy in their interiors. But new studies with the Gaia satellite have shown that there must be some other energy source keeping those older white dwarfs shining bright.
Something is giving these white dwarf corpses a spark, bringing them back from the dead as zombies.
The leading contender is that the insides of white dwarfs actually crystallize.
Up to 6 billion years after dying, the hot carbon and oxygen matter inside the white dwarf cools and crystallizes, becoming solid, giving the dead star a lifeline.
This actually releases energy. As the star cools, it winds up releasing a little bit more energy than it otherwise would.
This unusual heat source could warm up a nearby frozen planet, giving life a second chance.
There will be some extra energy available from these objects. So this is the time that we have to cuddle up close to the zombies.
Crystallization can rejuvenate old white dwarfs, and the process could even provide a spectacular setting for an orbiting planet.
We have a special name for cooled down crystallized carbon and oxygen. We call them diamonds. The long-term fate of our universe will be sprinkled with all these glittering diamonds.
A zombie that comes to life and shines like a diamond might be pretty to look at, but it's still no guarantee that life could survive here.
You can kind of think of these white dwarfs as maybe making a little more energy for the universe, but even that's going to eventually run out. The whole thing becomes a gigantic crystal, And again, it's just going to start cooling and fading away.
The zombie fizzles out into a dark cinder, giving off almost no light at all. But there's another monster lurking in the cosmos.
When a star that's much more massive than the sun dies, it explodes violently. And during that explosion, the core collapses and becomes an incredibly dense small object, one of the most wonderful, real monsters in the universe.
This is a pulsar, PSR B0329 plus 54, 3,000 light years away from us. The pulsar has the mass of the sun, but is just 12 miles across. Its rapid spin generates beams of radiation from its poles, bringing the zombie to life. Now we've discovered an alien world orbiting this zombie star.
In 2017, a new planet was discovered around a pulsar, about twice the mass of the Earth, and that's really incredible.
This pulsar planet sounds intriguing, but the prospects for life aren't good. Orbiting a pulsar would be a brutal environment for life.
It's highly unlikely that there's life because the radiation from the system would be overwhelming and likely blow away the atmosphere.
Perhaps it's time to think outside the box by looking at one of the most mysterious objects in the universe, a brown dwarf.
A brown dwarf is basically a failed star. It is a star that wasn't quite big enough or massive enough to cause hydrogen fusion at its center.
Brown dwarfs are much smaller than the sun, but they do generate some heat. And they have enough gravity to hold planets in orbit. But compared to a fully fledged star, they're small fry.
You could imagine a scenario where a brown dwarf forms with, a family of planets, but these planets won't get a lot of heat and light from that brown dwarf.
Planets orbiting a brown dwarf would freeze very quickly. But these almost stars do have a trick up their sleeve.
Brown dwarfs are incredibly common, and they often form binary pairs with each other.
What if you had two brown dwarfs that were right at that limit, just not quite enough material to actually start fusion? Over time, if they were in a binary star system, they could spiral together, maybe even collide and combine into a single star. And then these two failed stars would join together and finally begin to shine.
Two failed stars collide, creating a new Frankenstar.
You could potentially form an actual legitimate star. A star can start shining and warm up those planets. Maybe there's a chance for life after all.
As for sustaining life in the universe, none of these options is what you'd call a safe bet.
These are momentary reprieves from the inevitable. No matter what you do, eventually you're gonna run out of these gimmies. You're gonna run out of the get out of jail free cards. Inevitably, everything is going to cool and fade away.
This might be game over for stars and even life. But there's still a glimmer of hope hidden in the cosmos. A star that's not dying. It appears blessed with eternal life, and its color is red.
Red dwarfs. We are literally surrounded by them, but they are largely invisible to us.
Illuminating every corner of our night sky is the light of stars. But what we see with the naked eye doesn't tell the whole story.
The stars that you're seeing are mainly stars like the sun, or even more massive and even hotter than the sun. They're bright, you can see them from a distance. But amazingly, the most common form of star, by far, are the red dwarf stars. They're up there right now in the sky, but they're just too small and too faint to see.
Red dwarfs are up to 10 times smaller than the sun, and they burn less brightly. Right now, hidden in the night sky, over 3/4 of the stars in our galaxy are red dwarfs. And while the larger stars are dying out, we've never seen a red dwarf die, making them the best bet for life to survive the star apocalypse.
When the most massive stars eventually go out and are not replaced, what will be left are much, much dimmer stars like red dwarf stars.
We've seen star death across the universe, so why not red dwarfs? It turns out their size gives them a crucial advantage over larger stars.
The more massive a star is, the hotter it burns. A red dwarf star burns at a lower temperature, so it doesn't burn through its fuel quite as quickly as a mid-mass star does.
These are like the economy cars of the universe. They're just sipping on their nuclear fuel, and they can coast along.
Not only that, despite being smaller, they have access to more fuel. Our mid-sized sun is split into 3 layers: a core, a radiation zone, and a convective layer. The radiation zone prevents hydrogen in the top layer ever becoming available to the core to burn. So the sun can only access about 10% of its total hydrogen fuel. Once the hydrogen in our sun's core runs out, its days are numbered.
In some ways, these mid-sized stars end up starving themselves.
The smaller red dwarfs are different. They can access all the hydrogen they want.
In low-mass stars, outside of the core, this outer layer is fully convective. And what that means is stuff near the core rises to the surface and then drops back down all the way to the core. And that means if you have hydrogen somewhere outside of the core, eventually it's going to make its way down there, and it can be used for fuel.
The red dwarf has access to everything at the all-you-can-eat buffet. It can grab stuff from the distant regions at the surface of the star and bring it all the way down the gullet to the heart of the star.
This all-you-can-eat hydrogen buffet extends the lifespan of red dwarfs to incredible lengths. The universe is over 13 billion years old, but any red dwarf that age is a toddler.
A red dwarf, even if it was born at the very beginning of the universe when red dwarfs could first form, even today, it's just a tiny fraction of its lifespan. They can last for trillions of years, thousands of times the current age of the universe.
13 billion years old? That seems like a long time, but a small red dwarf, it's barely out of diapers.
Red dwarf stars will not die out for 10 trillion years or more. And we're discovering they have another trump card. That's good news for life. February 2017, NASA announced the discovery of a system in the Aquarius constellation called TRAPPIST-1, where 7 Earth-sized planets orbit a red dwarf star.
It turns out that red dwarfs, apparently, are really good at making planets, including planets that are roughly the size of the Earth. That's really cool, because these stars last a long time. If they have planets orbiting them with life, they could outlast our solar system by trillions of years.
Sounds promising, but red dwarfs have an ugly side. In October 2018, astronomers turned the Hubble Space Telescope to a series of young red dwarf stars in the Tucana Horologium Association. They witnessed these infants throwing daily stellar tantrums.
Even though they're the smallest stars, they actually have some of the strongest flares and storms on them.
Red dwarfs can emit flares 10,000 times more powerful than the sun. These flares would cook any nearby planets.
When a red dwarf star forms, they're rotating very rapidly, and this creates a lot of magnetic activity, which creates flares and mass ejections.
For life to exist, it would have to wait for infant red dwarfs to grow up.
As a red dwarf gets older, there's drag between the magnetic fields in space as it rotates, and that has the effect of slowing down its rate of rotation. And so this means the activity settles down. So maybe later in the life of a red dwarf star, they can support planets with life.
Red dwarf stars will dominate the future universe and may give life a chance to survive. These small red stars are extremely long-lived, but no star is immortal.
Even though they're really going through their nuclear fuel very slowly, there's just not enough fuel to last forever.
These little stars will die out eventually. Unlike their larger stellar siblings, they'll go quietly.
It actually just gets hotter, and the color of a star depends on its temperature. So as the red dwarf gets hotter, it turns bluer. So sometime in the very distant future, some of these red dwarfs are actually going to become blue dwarfs.
The universe isn't old enough for blue dwarfs to exist yet, but trillions of years from now, a dim blue glow will complete the star apocalypse.
There will be a last star, one last red dwarf, maybe now turning blue as it warms up. But it too will eventually cool off, fade away. And there will be no more stars in the universe. It is inevitable.
In this dark, starless universe, prospects for life seem impossible. But will something else take the place of stars?
As we get to the end of the universe, things get really cold, but they also get really weird.
Trillions of years from now, the star apocalypse will leave the universe empty and dark, a never-ending night.
The universe at this time is nothing like the universe of today. There's no light, and it's really cold and very lonely.
When all of the stars die and the light goes away, anything that relies on the heat and the processes from these stars will start to die.
Once all the lights go out, the only things that will remain will be the leftovers.
With stars as we know them long gone, could something else spark into existence in this cosmic wasteland?
You think that's it, no more star formation. But the universe still has a few tricks up its sleeve.
Over the history of the universe, generations of stars have lived and died. They released heavy metal elements into the universe, building materials for a new kind of star. And stars born from these new materials can do things their ancestors couldn't.
As you enrich the universe, as more and more metals get produced over time, you can lower the temperature needed for fusion reactions in a star.
With lower temperatures needed for fusion, stars have become smaller and smaller.
Currently, the smallest possible star is a little under 10% the Sun's mass, but eventually it may be possible to form stars that have around 4% the Sun's mass.
Hundreds of trillions of years in the future, a new star may dominate the universe, built from scraps left over from generations of dead stars. A star so small that it burns cold instead of hot.
One of the weirdest types of stars that scientists hypothesize might exist in the far future is the frozen star.
You can start forming stars that are very, very small and very cold, where nuclear fusion is happening in the core, but the surfaces are cold.
These small cold objects will be thousands of times dimmer than the faintest star we see today. So cold, the temperatures on the surface could reach just 32 degrees Fahrenheit. And ice clouds may form in the star's atmosphere.
They are so much cooler than stars now, they could actually have ice, water ice, on their surface, even though they are technically stars.
It's literal water ice covering the surface of a star. The same ice that you can use for ice skating or ice racing or curling. You could do all of this on the surface of a star in the far future.
It's hard to predict if life could arise on planets orbiting frozen stars. We won't know until one appears. And that won't be for a long, long time.
The universe is far too young for even the first one of these things to even be a glimmer of an idea. So if you want to wait, a quadrillion years, we can find out.
Stars help create us, building and spreading the ingredients for life to develop. But the coming star apocalypse may mean the end of life, just not for a while. Small red stars will continue to illuminate the darkness, safe havens for life to survive and even flourish. As for us on Earth, we should be most thankful for one star, because without it, we simply wouldn't exist.
I really want you to never experience a sunny day again and not think about this. The sun someday will burn out, and so will all of the other stars. We are in this wonderful era of light and warmth coming out of the sky, and everything is going to go dark, absolutely everything, everywhere in the universe. So for the time being, enjoy the light, step outside, enjoy the sun, and think about how lucky we are to live in this time.